Our last method of factoring coming up right now. So we've had factoring out the greatest common factor, we call GCF, factoring the trinomials where you need a pair of numbers that multiplies to the third term and adds to the second. This one is called the difference of two squares. The word two doesn't show up there, but difference of two squares. So it has to do with square roots. Let's review that quickly. The square root of 49 is 7 because 7 times 7 is 49. So the square root of 81 is 9 because 9 squared, or 9 times 9, is 81. This might look a little new. The square root of x squared is x because x times x is x squared. So we will be working with perfect squares. That is a number you get when you square a whole number. So these should look familiar. And they keep going. I'm just going to write them out until, let's say, 144. Now they keep going, but this is 1 squared, 2 squared, 3 squared, and so on. So these numbers are the perfect squares. Okay, so first we will review multiplying binomials. Remember, we had some that looked basically the same, except the signs were different. If you recall, something happened. We have x times x. I'm just distributing now. Negative 5x. Now 5 times x. Positive 5x. And then we get a negative 25 here. But see how that cancels the 0? That's because we have two binomials that look alike, except the signs are different. When you have that kind of multiplication, you create a difference of two squares. Now we're going to be going in the other direction. We're going to start here and end up there. But I just wanted to review multiplying first. Here we have distributing, we get a 4x squared minus 6x plus 6x, there's your canceling in the middle, minus 9. And they always end with a subtraction because you're doing a positive times a negative. That's a good difference of two squares. So now our objective, actually, there's a section of the homework where you practice that multiplication again, which is why I did that. So basically, there's two steps. It says determine equal factors. Well, how do you do that? You take the square root. Because remember, our answers have to look like these problems up here. So you take the square root of 4x squared. You get 2x. Put that at the front of the parentheses. You take the square root of 36. You get 6. You make 1 plus and 1 minus. It doesn't matter which goes first. So I only have 4 examples. Let's take a look. So these are difference of two squares. They're all subtraction. That's why we call it a difference. And on each end of the subtraction sign is a perfect square. That's why we call it the difference of two squares. So we make our parentheses. And we just take square roots. The square root of 9x squared is 3x. The square root of 1 is 1. And again, remember, one of these must be addition. One of them, I'll make that again, it didn't show up real well. One of them must be subtraction. So that's really it. Our fastest method of factoring we save for last. Square roots 2n and 7. For the square root of 49. 1 minus, 1 plus. You can try these two. Pause the video. I'll just get set up here. Okay, square root of 36k squared, 6k. Square root of 1 is 1. And that's factoring a difference of two squares. And as we saw above, if we multiplied this out, we would end up with that difference because we would get canceling in the middle. Square root of p squared is just p. Square root of 36, as we've seen already on this paper, is 6. I'm done. So let me show you the assignment, because the top of it we will review multiplying. So this is the distributive property, just like I did on the notes here. Okay, so practice that. And at the bottom are just a few where you will take the square root, factor the perfect squares, the difference of squares. Don't worry if you have two variables, it'll still be a y on the front, the square root of y squared, and a 3x second, It's okay to have two variables. It doesn't make this any more difficult. But as always, if you have any questions, let me know.